Hello, let's talk a little bit about pH. And pH, you can read in your book, and you've been familiar with over the years about it's a measure of the acidity of a solution. And we want to talk in this video about the calculations involved in this. And so pH is minus the log of the hydrogen ion concentration, more appropriately minus the log of the hydronium ion concentration. Remembering that in water we don't find H pluses protons floating around on their own. They combine with water to make the hydronium ion. So H plus and the hydronium ion are synonymous. At least from a calculation standpoint. And so we've got a few problems that we want to try here. And the first one is 1.0 times 10 to the minus 3 molar HCl. Let's calculate the pH. Minus the log of 1.0 times 10 to the minus 3 is going to give us minus 3.00, which is a pH of 3. You can get that by using your calculator, or you can if you remember that the log of 1 is 0 and the log of 10 to whatever power is just the power, then you got the log of minus 3, and pH is minus the log of minus 3. And so you can do it in your head if you have a 1.0 concentration to whatever power of 10, or you can use your calculator. Let's find the pH of 8.5 times 10 to the 5 molar hydronium ion. So we're going to do minus the log of 8.5 times 10 to the minus 5. And plug that into your calculator. And you get minus 4.07. And so that answer will be 4.07. Now you're questioning me at this point, what about sig figs? We're dealing with logarithms, and the rule for logarithms is that significant figures and log numbers are the digits after the decimal place. So back to our first problem, we had two significant figures. That means we're going to have two decimal places. A log number is made up of a characteristic and a mantissa. And so the significant figures are found only in the mantissa. The characteristic is the number in front of the decimal point. The mantissa are the digits after the decimal point. So only the mantissa reflects the number of sig figs. So 8.5 for molarity gives us a 4.07 pH, and so that 0.07 gives us our two decimal places, which refers to the two significant figures. 1.0 molar HCl. Let's calculate its pH. So the pH is minus the log of 1.0, and the log of 1 is 0. And so the pH is 0. This may cause you some angst. People sort of tend to think that pHs have to be between the numbers 1 and 14. That's not correct. pH can even be 0. Which brings us to the next problem. 12 molar HCl. So the pH is minus the log of the number 12. And so if you put that in your calculator, you'll see a positive number as opposed to a negative number that we've seen thus far. And so we have a pH that's equal to minus 1.079. It's actually a negative pH value. 12 molar HCl is the concentration of concentrated hydrochloric acid, and so it actually has a negative pH. And we had 3 sig figs in our original number. That means I'm going to have 3 decimal places in my pH number. So that's calculating pH of various solutions.